All right. Well, welcome. I'm very excited about our presentation today. We have Shivani Linger and Christy Bickle from Stantec, and they're going to be talking about green schools, creating a healthy and productive environment for all students. So I want to welcome you and tell you a little bit about SPEAR and the City Efficiency Leadership Council. If you're less familiar with the City Efficiency Leadership Council, it's a partnership program with the State Energy Conservation Office to support outreach and education-focused programming. And it mainly supports the energy sector management, but also sustainability in Texas and Oklahoma. We offer webinars, regional roundtable meetings, technical resources, and reports. And then also we have resources in assisting people with understanding greenhouse gas inventory, as well as going through the process of collecting their information for their energy reporting to the State Energy Conservation Office. So cities in the title, but we do offer these resources and opportunities to all sorts of public sector entities, including counties, universities, and school districts. And if you haven't done so, I encourage you to take some time to browse our local government section on our website. Here you'll find information on local government energy reporting, more about CELC, as well as a toolkit that we have put together. And to all of you that are attending today, you'll receive follow-up information about the program, and feel free to reach out and let me know if you have any questions or how you'd like to get more involved. And also we should take a step back and talk about SPEAR. It's a South Central Partnership for Energy Efficiency as a resource. And it's one of the several regional energy efficiency organizations in the nation. There's about 5 of them. And so again, we cover Texas and Oklahoma. A couple of announcements before we get into our presentation. We have some current events. Our next webinar is going to be on building operator certification. Our next webinar is Energy Code Basics and Building Thermal Envelope 101 and HVAC energy savings. And that will be with a project manager from SPEAR, Jason Vandeveer. And he is full of information, so I'm pretty excited to hear from him. He's the kind of person that you can walk up to and say, is there a code for pool energy efficiency? And he could tell you exactly why and go into a conversation about that right off the cuff. So it's going to be an exciting one. And then we also, SPEAR offers a building operator certification training course, and that will be coming up in mid-September. And then, of course, this webinar, we offer ICC CEUs. And so you must fill out the survey, and I'll put it in the chat at the end of our webinar. And so if you want to receive those CEUs, then please respond. And it's always great to get feedback on how we can improve these webinars or other ideas on what you would like to see and information you would like to learn about. Oh, and if you're calling in, please put in your phone number into the survey so that I can coordinate the phone number with the person's name. All right, before I get started in doing the introduction for the speakers, I did want to say that we have a chat box. And so how this will work is you are, of course, muted, but you're welcome to put questions in anytime, and I'll be moderating questions at the end of the presentation. But it's great to put those questions in when you think about them, and I'll address them. And if there's any issues with technical aspects such as the volume, or if you can't see the slides, please send a direct message to me. It's greatly appreciated. Technology, I always take it with grace. And I also need to add that I'm Sean Auckland. I am the local government program manager here for SPEAR. And I'm very excited to welcome a colleague, and also serves with me on the USGBC Central Texas council here, and she is the co-chair of the Green Schools Committee. And I am excited to welcome Shivani Amlinger and also Christy Buckle. So I'm going to give Shivani a minute to bring up her presentation. And as she does that, I'm going to bring out a poll. And so if you could answer this poll question while she brings that up, I would appreciate it. And the poll question is, which most closely aligns with your profession?
Sean, I think you have to stop sharing before I can share. Oh. It's telling me.
Thanks, Shivani. There we go. Is that easier?
Perfect. Perfect. Great.
Okay, as she's doing that, so far the feedback is school districts, code officials, and architects. Fantastic. Well, you all can continue the poll, and Shivani, why don't you go ahead and get started? I look forward to hearing more about you and Christy.
Awesome. Thank you so much. I'm guessing everyone can hear me okay, Sean? Good. Okay. Great. So Sean, thank you so much for that introduction. And I will give a brief introduction about Christy and I. I am a principal and senior project architect with Stantec. I'm also the regional sustainability leader for the US Central region for Stantec. Christy and I have been working on sustainability research and benchmarking program. So we are lucky to have a program such as we do here in Stantec, where we do a lot of research along with practice. So we think that the research is making us, informing us about new technologies, anything else that's going on, but also helps us inform and give us feedback. If we do research, we can inform ourselves about what's working and what's not working and what should we be implementing in our future projects. A lot of our discussion today is going to be about that. Christy is also a principal and senior project architect with Stantec, and we are here to talk about creating healthy and productive environments for all students. I'm guessing y'all can see my screen.
We can see your screen, Shivani.
Awesome, perfect. And just briefly, what we expect you all to learn from this presentation is that we are going to talk about post-occupancy evaluation. And that's what we concentrated on in this research today that we're going to talk about. And how do we define post-occupancy evaluation? What is the process and who is involved? We are also going to talk a lot about the well building standard. And because our post-occupancy evaluations did go a lot deep into what the users think and how our buildings affect our users, and the well building standard goes really hand in hand with health and well-being. We are also going to talk about, because of the post-occupancy evaluations, what kind of design strategies we figured out that work or may not work with what our design intents were and with what users want. And then we also hope to figure out what kind of research needs exist in our industry and how our research program and other research programs can help our industry as we move forward. So what is post-occupancy evaluation? And this is a question that gets asked a lot because a lot of the times and I'll call it POE, that's the short form that we use for post-occupancy evaluations. And a lot of the times POEs are considered to be very quantitative. It's all about, hey, let's collect data about how the building is performing, how much energy is it using, how much water is it using, but we did take it that extra step that we make it qualitative analysis. We usually try and survey a building between 1 and 3 years after occupancy. Within the 1 year, it's really tough because people are still getting used to the building and the building is getting used to its users. So we do try and mostly conduct POEs 1 to 3 years after occupancy. And we will explain what we mean when we talk about qualitative analysis. So what was our process to do a POE? We do a user satisfaction survey, and we use a third-party survey, which is by the Center for the Built Environment, and I'll talk about it in a second. So that survey is done by the adults, is taken by the adults in the schools, and it's a third party. We are not able to edit that survey, and that was a big deal. We really wanted it to be an unbiased survey. And then our POEs are quantitative as well. So we do collect energy and water data from our all the utility bills from our schools. We conduct project team interviews because Christy and I, even though we were leading the research, we haven't worked on all the projects. So it is important to hear from the team, why did we get the results that we did? And then we analyze the data. The survey analysis is a big part of this discussion. And then we share our lessons learned, just like we are doing today among our design teams as well as the industry. And then why? The whole presentation is about why. Why do we do this? Is because, even products such as a microwave has customer service, customer reviews, right? We always look at reviews in Amazon if we buy anything, but how is it that we never want to go back and look at what our customers or our users think about our buildings? Let's do that. Let's do that through our POEs so that we can inform future designs. We can figure out what are the issues and also get those issues resolved while the building is being occupied. So let me talk a little bit more about the surveys. Like I mentioned, it is a third-party survey by the Center for the Built Environment, which is a University of California, Berkeley organization. They have had an indoor environmental quality survey for years. And they have these categories that are listed, the 10 core building categories. And we're going to talk about some of those categories today. But you can see that all of them relate to IEQ, thermal comfort, acoustics, air quality. But we are also able to add 4 specific survey categories, which the school has a choice of. The school can choose to survey maybe automatic faucets, or they can survey daylight sensors, or so they can have, or sunshades or some. So they have the choice to pick some survey categories. But also in our study, we added views in daylight for an additional cost. So yes, there is a cost associated with these surveys. But it is a kind of data that we get is phenomenal, and so we have been spending that money to get to do these POEs. And the user online survey style. So everyone, kind of always asks us, are they only able to do checks, or are they only able to tell you what percentage satisfied they are? So as you can see that, yes, you can say very satisfied to very dissatisfied. There are many levels of that. But once they say that they are dissatisfied, or however they answer that question, then another question pops up to say, why are you dissatisfied? And there are some options already listed, but you can say other, and then you can list any whatever else that you could be dissatisfied with under that category. And then it is an anonymous survey. We do not ask for names. And the only thing that we can ask them, which really helps us a lot when we do the analysis, is, hey, which floor are you located on? Are you facing the bus drives? Are you facing the parent drop-off? Are you facing the fields? And that way we can figure out which orientation does their workspace face. And that really helps us from the analysis that you see we do. You can tell which orientation do those comments are coming from. And then you can see that on the right side bottom, you can see that their responses can be really detailed. Some we truly appreciate when people take the time to tell us their responses, because those have been the most important part of our analysis, because then you can tell why the dissatisfaction. And then, like I said at the beginning, we are going to talk about well building standard, because for those of you that may not be familiar with it, it is, I know a lot of people are familiar with LEED rating system when it comes to green building rating systems, but WELL was started by International Well Building Institute. And it is all about the health and well-being of occupants. And there are the 7 concepts that you see there. Now, we are talking about well version 1 in this presentation because that's what we were looking at when we did the analysis. Well version 2 just came out of its pilot. So there is another version of well currently in place. But what we are talking about today, all of those are still very relevant, whether it was version 1 or version 2. And if you look at the well, both in version 1 and version 2, post-occupancy evaluations by a third party is a precondition to get certification. So it is very clear, even in the industry, that if you are talking about health and well-being of occupants, you have to survey them for 3 years in a row to ensure that the building is performing well when it comes to their is treating them well, for lack of a better word, but how do they like the building? And I just have a couple of other things here, that it is a third party certified, just like LEED. It has 105 features. So you think of LEED points, it has the same, or LEED credits, it has features, and 41 of those were preconditions in version 1. So we'll talk a little bit about each category and how well relates to each of those categories. So today, what Christy and I are going to talk about is the post-occupancy study that we did in 4 middle schools in Texas. They are similar climate zones, similar program scope, and that is actually intentional. When we do POEs, we don't do it one school at a time. We do a combination of schools so that we can compare one school with the other, and everything can be compared in terms of design intents and in terms of satisfaction. So we've been very successful when we do them together, and we try and put like middle schools together, elementary schools together. So we are also looking at similar program and scope. So that's what we did, 6 elementary schools way back in 2013. But today we're going to talk about middle schools that we did sometime in 2016 to 2017. And then we have been wanting to do POEs, but COVID has really, we have struggled with, since 2019 school year, we have struggled doing them because of COVID. So the 4 middle schools, we are not allowed to give you names. So that's why we're going to talk about them in 4 different ways. Energy Star Middle School. This is in Central Texas. It was designed to per Energy Star rating. Then the Central Texas Middle School is just another school. All of these schools had sustainability intent to some extent. Some were designed to a certain level and some were not. Then the Houston Middle School is another middle school in Houston, and then CHIPS Middle School was designed to the CHIPS standard. CHIPS is another rating system for schools. And all 4 middle schools are they similar program, just like all middle schools do, but they did range in area from 160,000 square feet to 250,000 square feet in when it comes to the CHIPS Middle School that you see below there. And they were constructed between 2009 and 2013. So 2009 was not within the 1 to 3 years of occupancy, but we did want to study that because it came very close to the other Houston school that we were studying. And then the survey analysis that we do, the CBE is great about telling us constantly how many people have taken the survey yet. So we are able to, during the 2-week period that the survey is open, we are able to constantly send them reminders or tell the principals of the schools to send them reminders. Well, version 1 at some point had 30% response rate is considered good. And we were able to, in some schools, get 85% response. So that was very, very good in terms of analysis. We always want to get more responses so we get better analysis. And then we analyze the data, the graph that you see at the bottom. That's, in a screenshot, you can see how we performed in different categories. But I want you to look at the purple one. So the 4 different other colors are the 4 middle schools. But if you look at the purple one, the best thing about CBE survey, doing the third-party CBE survey, is that you actually get to see how your school performs in relation to the other schools in their database. So the purple line tells us percentile data and how our buildings performed as an average of all the other buildings. And so that is also very beneficial data. And then some of the categories within the survey is related to office furnishings and cleanliness and maintenance, which may not necessarily be something that architects might be concerned about or have a say on, because we don't do furnishings a lot of the times. But at least after this, we can inform the clients that, hey, this may be something you might want to change in a future school. And then the other categories, that thermal comfort is a really tough category. As you can even see with the purple line, it is a tough category to get high user satisfaction on, just because it's so personal. Everyone has a different level, and Christy will talk a little bit about that too. And then lighting is another one. I just want you to remember this one, that one of the schools, Trips Middle School, did not do very good with lighting. We were actually lower than the CBE average. And we will talk about that as well. So I will hand over to Christy now to talk about the first category in indoor environmental quality that we wanted to talk about.
Well, today we want to start off with the importance of acoustics. The acoustic quality of space really has the ability to affect our social behavior and our productivity. So it's really important in regards to design for people's well-being. Next. So these graphs are how we are able to dissect the data from the survey. The top graph shows overall user satisfaction with the acoustics of their workspace. The gray bar are how we did in relation to the CBE average, like Shivani was talking about in the purple on the previous graph. And it shows that we did pretty high, we had a pretty good satisfaction rate when we compare ourselves to those other schools surveyed by CBE. The orange bar shows the specific satisfaction rate of the occupants of those buildings we surveyed, our buildings that we surveyed. And so 2 schools had about an 80% satisfaction rate, and the other 2 had just under a 60% satisfaction rate. And then the chart below shows the specific reasons the users could identify why they were dissatisfied. And one area of concern for pretty much all 4 schools, if you see to the left side, is noise from adjacent spaces. And when looking at the raw data, we found it difficult to pinpoint the issue when the users did not provide the additional comments. Again, like Shivani said, the additional comments help us identify where those issues are so we can look more into them. However, the CHIPS Middle School, their evaluation had a lot of comments, which provided us some specific areas to look at in more detail. So as part of our evaluation, we actually visited the CHIPS Middle School to kind of hear firsthand the issues they were dealing with. Next. But before I talk about the CHIPS Middle School, we kind of want to just make sure we're all on the same page on a couple of terminologies here. So when we say decibel, we're talking about the measurement of the intensity of the sound. And that chart kind of shows a graphic representation of what we're talking about. So if you look at around 40 decibels, it's like light rain. 50 is like your refrigerator running, and 80 is like a truck. And then if we talk about STC, or sound transmission class, it's the rating of how well a building component attenuates sound. So like when we're talking about a partition, to get a better STC rating, you would increase its mass, air tightness. And so an STC of about 40 is loud speech. You can be heard, but an STC of 50 is where you could be yelling and you could still hear a little bit, but not too much. So in general, between 40 and 50 is actually considered pretty good. But again, sometimes noise disruption is subjective. So now we're going to look at the specific issue of the CHIPS Middle School. So one comment was regarding the foldable walls at classrooms. The quote says, "We have foldable walls and we can often hear what's happening in the classroom next to us while teaching." And so the foldable walls really are a design strategy to increase flexibility in schools. But if we can't provide adequate acoustic separation when the rooms are used separately, then we've not given them a lot of flexibility in reality. So when we visited the school, we took some decibel readings in the quieter classroom. And the adjacent classroom had a full active, a full classroom. The teaching was a very active and teaching environment. But then when we went to the other classroom that had like 4 or 5 students in a quiet setting and took a decibel rating, it was rated at 45, which, as we said before, is actually pretty good. But the fact is that the different activities, the quiet worked, even though it was acceptable rating in general, it wasn't really acceptable for their activity. So even though it's an acceptable rating, it still can be distracting. So what do we do if we're still trying to provide this acoustic separation and flexibility? This school in particular, originally that movable partition had been specified as an STC rating of 54. However, it was VE'd to a lower rating. So again, if that higher STC rating had been provided, they may not have had those issues between those classes. Secondly, you need to make sure that the teachers know how to operate the walls correctly. They do have seals that have to be locked into place. So if they're not adjusted, if they're not closed correctly and adjusted correctly, there can be noise leakage between the classrooms. But a benefit to these types of flexible classrooms, especially in times like we've been living through with COVID, is these spaces allow the schools to keep a more, they can open them up and provide larger classrooms to allow that social distancing that they've been working with as school has gotten back into sessions over the past year or so. So again, the flexibility really just gives the district a lot more opportunity to meet the needs of the teachers and the students. But again, we can't sacrifice acoustics when we're talking about flexibility as well. Next. Another location where they talked about adjacent spaces and noises was the cafeteria. We again visited this cafeteria in full swing. It was midday, lunch was going, and we took decibel ratings in that cafeteria, and it actually came in at about an 80 or 85. Remember, that's like a truck, which, when I think about a truck, it doesn't necessarily bother me on a daily basis, but depending what I'm doing, it might be distracting. So we went to 3 different areas of surrounding the cafeteria. You can see there's 3 kind of orange spots on the plan. And we kind of took noise ratings from those different classroom types, either the classroom or it was I think it was a home ec type room and then a large group. And again, our decibel ratings came in at one of those satisfactory rating. But again, if the classroom's quiet and there's a big din of cafeteria noise going on, that still is distracting. And so we kind of, as designers, have to kind of remind ourselves that, maybe putting quieter spaces adjacent to these louder spaces isn't the best solution. But whenever we have to do that, maybe we can up the STC rating of the partitions separating those areas. You could add maybe little vestibules to those classrooms for the door, the issue with the doors opening and closing and sound coming in from outside. So there's things we can do when we need to do that, but we also need to think about whether or not that's the best place for those types of classrooms. So, sorry, one more. The other thing is you can also address some of those issues in the cafeteria. All the walls in this cafeteria went to deck. They had some acoustic panels, and there is some acoustic ceiling, but the deck wasn't acoustic. There's a lot of hard surfaces. So, maybe adding an acoustic deck would have been helpful, or more additional sound panels, something like that, to help with some of that mitigation of the noises, all the hard spaces there. Next. So the Central Texas gave us some comments regarding their school as well. One comment was, we hear toilets flushing every time someone uses it, which obviously people don't want to hear that at school on a daily basis. But we talked to the team, the walls went to deck, they had sound insulation, but again, maybe that's not the best place to put a toilet adjacent to those classrooms, but schools have to have toilets nearby for supervision and all that. So, maybe we need to be looking at a better STC rating of those walls. Just kind of being aware of where things are in the plan and what kind of noise can happen in those various spaces. The other thing from this school. It was the library. They had comments about hearing noises from above and walking down the corridors and moving the chairs and tables. And so we really need to think about not only horizontal adjacencies, but vertical adjacencies. So when we're thinking about vertical adjacencies, we need to start thinking of the, let's see what's called, the impact insulation class of the floor and ceiling assembly. The floor and ceiling assemblies and associated floor covering can help us increase the impact insulation class number, which can help reduce the sound transmission to the lower levels. And so you can address the issue either above or below the deck or a combination of the two. And some strategies include selection of floor finish materials with a higher IIC rating, or adding an underlayment to the flooring, and also adding gypboard ceilings assemblies below the deck. The library in this case actually had some exposed deck area. There wasn't a lot of separation between the classroom above and that library. So again, really thinking about that assembly between the vertical spaces is really important. Next. So to sum up some of the architectural design considerations we have, is reverberation time increases background noise. So use hard surfaces and exposed structure with caution. Also consider the path of travel sound can take. All three of our examples could benefit from those kind of considerations. One thing we didn't really cover is mechanical noise issues, but in general, when you limit the space available for the HVAC ductwork, you can get increased air velocities, which also increases noise in the ductwork. So those are some things that you want to be aware of. Next. So in regard to the WELL building standard, acoustics is under the concept of comfort, and data shows how acoustics can affect teacher and student well-being. And the WELL building standard aims to enhance learning, productivity, and social interaction. So WELL is recognizing acoustics as an important concept, and because of that, it has set preconditions that must be met, such as limiting exterior noise intrusion and limiting internally generated noise. I'll send it back to Shivani now.
Perfect. Thank you, Christy. I'm trying to move it. Okay, great. Thanks, Christy. So the next section that we're going to talk about is daylighting. I'm watching the clock, and hopefully we'll have time for, we really want to have time for questions, so it'll be a little bit quick now, but yes, surprising. This was one of our surprising categories where, as you can see from the quote up there, more is not always better. So we always, we always survey daylighting in our POEs, and the big one that we saw here was that we did not, as anticipated, especially in our really nice flagship schools, we did not anticipate lighting percentage satisfaction to be low. But as you can see, especially the CHIPS Middle School and Houston Middle School were pretty comparable, but Houston Middle School was an older school and CHIPS was designed with daylight harvesting. So we were kind of taken aback a little bit, and you can see some of the comments on the right side that talked about glare. A lot of it was about too bright and too much glare. So we looked at the plans. Like I said, we do a lot of project interviews. We do a lot of checks of what actually was happening. And the Houston Middle School just had those 2 punched openings on the side of the classrooms. And by looking at the data, like I said, you can tell where people were, where you can tell which floor they were in. And, we saw that the percentage satisfaction or dissatisfaction, where is it coming from? But then the CHIPS Middle School had wall-to-wall glazing when it comes to north and south facades. All the classrooms that you can see in the plan had wall-to-wall glazing, really well designed, as you can see from this section, that we had sun shades, light shelves, sloping ceilings that brings light all the way into this classroom space. So it was designed completely in keeping with the daylight harvesting strategies. But again, we got tons of comments from from the survey that said glare from top windows that do not have blinds do not allow us to do projection. So we decided, okay, let's go visit the school. So we went down to the CHIPS Middle School, and we realized, now this is after a few years of occupancy, right, that the blinds that we had never installed on the top of the light shelves were now there. So they had added the blinds above in the clear story windows, and those blinds are inaccessible, so they're always closed. And we also could see very clearly that there was a lot of glare on the smart board and the marker boards. So it was the reason why we were getting so much dissatisfaction. Then we remembered that from our previous elementary school surveys, this was exactly what we had seen, that the top two pictures are from the older elementary school and the bottom two are from the newer elementary school, that the older one had 2 punched windows, and the lower one again had, the new school had wall-to-wall glazing with sunshades and light shelves. But the percentage satisfaction for lighting in the old prototype was way higher than percentage satisfaction for the new design. And we did really badly when it came to the percentile rating from CBE. So this was, again, the elementary school study, and then the middle school study showed us the same thing, that there was a question about, or there was something that wasn't working when it came to glare. And, there was a reason why we did wall-to-wall glazing. There was a reason why we did daylight harvesting when we did, because it did give us higher returns in previous energy codes from light savings. So the artificial light savings was definitely a lot more when we were designing in previous energy codes. But with IECC 2015, we have been doing LED lighting for a long time, and that return payback is not much. So we also have to remember that we have to do technology that can work with bright light. And again, in that project, that technology was it was more costly, and it was value engineered out. And the other big one, and Christy mentioned that a little bit too, that how do the folding partitions close? Sometimes the dissatisfaction that we have seen a lot of times is because people do not know what works and why. Why did we design the way that we did? What are the daylight sensors? What are the controls that they have? And it is really important for us to have constant training of the occupants to ensure they understand the building and they understand how the building is supposed to be used and the reasons for the designs. So I mentioned in the first few slides that POEs do take us to future research. And this, what we did once we got those surprising results from POEs, we went ahead and did this very extensive daylighting research with fenestrations in classrooms. These are all 5 different kind of configurations of windows that we have done in classrooms. And we're like, okay, let's go ahead and study what works and what doesn't work, right? Why are we getting such low satisfaction rates? And if you see, the study ranged from 28% window to wall ratio to 58.2% window to wall ratio. So in no way the study or this presentation is meant to say that there should be no daylight. Absolutely no one can argue that daylight is great for everyone, and especially for younger kids, and especially in a classroom setting. And then we asked ourselves, in that research, we asked ourselves questions like, how does glazing size and orientation and configuration, sunshades and light shelf affect the daylight quality? And again, this is a completely different research, and you can find it. We have presented it a couple of times and published it as well. So because of what our users told us, we now have data that proves that why should we be designing for more fenestration when energy codes are saying 30% window to wall ratio is the ideal window to wall ratio. If you do more, then you have to prove why you did more. When we we proved in that study that the 28% gives us enough light. Like when you talk about amount of daylight, it had way more than all the points that LEAD and WELL give us. So we were still within that, but we can talk about that study at some point. But I really wanted to show that how POEs can inform future designs and future research. So again, ending this category with talking about WELL, and yes, absolutely, that WELL recognizes glare is a concern. We cannot just take daylighting and talk about amount of daylighting. We want to talk about quality of daylighting. And that's why the visual balance, that's why glare is very, very important. You need to have shades, you need to have blinds, but what we question is, why do we rely on those things? Why do we design it to begin with? Just like you saw in the CHIPS Middle School, where the blinds were closing the clear story windows all the time, then was it worth it? Why, we probably now with the new energy codes need to rethink the amount of daylight, or more is not always better. Perfect. I'm going to hand over to Christy again.
Okay, for overall design, we kind of talk about how satisfied users were with their workspace. So looking at it in general, we did pretty good when it came to overall satisfaction. However, we wanted to kind of point out that everybody, this is particular to classroom sizes, because most of our survey users are teachers, and so they work in classrooms. So a lot of comments were about classroom sizes. They say too many desks, not enough room. We discussed flexibility when we talked about the partition, and we're seeing teachers and students moving to a more flexible learning environment. So as design professionals, we need to make sure that when we're programming and designing new schools, we're accommodating the various teaching and collaboration that's happening in these spaces now. We also need to understand the number of students that we're accommodating in each class. So if we think there's 25 students in the room, but really they have classrooms with 30 students, obviously the flexibility is just out the window at that point, because even 5 extra students in that classroom has really limited the flexibility of that current classroom size. So again, building in flexibility and knowing what the capacity is very important. And then just in general, flexibility for the teachers. Historically, we had a teacher home base, but as the classrooms are becoming more flexible, the teachers want that flexibility too. But also you have to think about this as these schools are several years older, and so they had some limiting factors at the time, including budget constraints and available technology. Sorry, I didn't tell you to go next, did I? These are just kind of the classroom configuration issues that they've been working with, the teacher station versus being mobile. And so with the new technology, and the wireless that's seems to be more readily available, the teacher flexibility is becoming less of an issue. Student flexibility with their seating configurations and choice of seating is kind of part of this whole satisfaction rate that we're looking for now when it comes to flexibility. So next. So this is it's an award-winning middle school we designed, of course, a few years ago. It opened a few years ago, where the classroom spaces they're in that blue area on the south side of the plan. They're kind of around the perimeter. That's what's considered classroom spaces. And then in the middle of the blue area, it's just a large open space that's used for, it's used mostly throughout the day. The classrooms are actually only used for limited amounts of time. The entire classes and the teachers spend most of their time in these larger open spaces. So this school in particular really was looking for flexibility where, if they needed to bring kids into a classroom for some specific one-on-one instructions, they could do that. But yet the majority of the time they're spent in that large, open, flexible space. It's got, bright lighting, interesting colors and patterns. And it's just it's a much more inviting place to be. and to study and to learn. And let's see. They also had some smaller group rooms. So here you can see that I think they had about 2 or 3 actual classrooms, and then they had like 4 smaller group and then some conference rooms. So this school had almost none of the typical kind of classrooms you would see in a normal school. And the flexibility that's allowed for that, for those teachers in this type of environment is something that they're all learning to use. And I think it's something that the students and the teachers all really enjoy and appreciate, the flexibility that's given to them when the space is something like this. And they're given the choice of size of space to be in and the flexibility of the furniture and the spaces that they're allowed to teach and work in. So the Well Building Standard has identified healthy work and learning environments should be designed to mitigate stress and optimize productivity, and therefore be sufficiently adaptable to working and focusing and collaborating, all these things that we do throughout the day. There needs to be spaces available for all types of work that people do based on their level of engagement. There are no preconditions for this category, but you can qualify for optimization points by having different types of spaces available to users, which is key to well-being. Next. This is my favorite one because the cold never bothered me anyways, but honestly, I'm always cold. I'm in a sweater right now. Thermal comfort is very subjective to each person's experience. So like Shivani said earlier, that's one of the more difficult categories to get user satisfaction. So here in this graph, you can see how difficult it is. For the most part, it's hard to get 60% or more user satisfaction. One user comment from one of our schools was, we share heat and AC with another room. It's not always comfortable in each room. A lot of decisions are taken out of the design team's hands. It's budgetary reasons. So there may be 2 classrooms who share a thermostat. And then also districts usually have set points for their thermostat. So even if they have some control, they have limited control over their thermostats. Sometimes the culprits for dissatisfaction is actually scheduling of the systems. They may be assuming that after hours, the units don't need to be running, but there are some after school activities that might be taking place in which the system needs to be running. So when we share this information back to the district, it helps them start a conversation on how they might adjust scheduling of the systems or set points, help mitigate some of the issues that we're hearing and that we're reporting back to them. And again, Shivani said training. We need to train the users so they understand why it is the way it is and how much control they have, and giving the feedback back to the district so that they can help them when they have issues. Next. Air quality can also be affected by scheduling issues or decisions. The Energy Star school commented in the air quality category because of how stuffy the band hall got as the day progressed, and consequently it smelled bad. But this was again addressed by revised scheduling. Sometimes there's like a non-functioning vent, and then we find out that someone had a sulfur smell somewhere. Well, we're able to pinpoint where that is. They're able to go in and fix the vent, and then they didn't have an issue anymore. And so, just helping to identify the issues and helping them solve the issues with the users. Next. So sometimes thermal comfort is sacrificed for energy conservation purposes. So one comment in the thermal comfort slide had said, the room is very, very hot. It's tough to concentrate. Well, Shivani's going to discuss the actual energy usage portion next, but we were interested in finding out whether or not thermal comfort satisfaction rate was tied to the energy efficiency of the building. And so this graph, you can actually see the thermal satisfaction percentage in relation to the energy efficiency of the building. And you can see that the Energy Star Middle School had the lowest satisfaction rate when it came to thermal comfort, but they also had the lowest energy usage as well. So there needs to be a balance between the two, and there needs to be an understanding of why and perhaps additional training given to staff relating to the issue. Next. So the WELL standard is concerned with thermal comfort because if the occupants of the building are not comfortable, then they'll take alternative methods, such as adding a fan or a heater to their space, which we don't want them doing. There are preconditions for WELL to meet thermal comfort, including providing all spaces to meet ASHRAE 55. I'm not going to go into what that is specifically, but there's also an optimization when it comes to providing a 5-degree variation and 50% free address and open offices. So meaning providing spaces with 5-degree temperature variation, and then people have the opportunity to move their personal workspace to the area which they're more comfortable. So providing, again, more flexibility in where people work and where they're more comfortable. Back to Shivani.
Perfect. Thank you, Christy. So yeah, I know we are talking about lots of technical data, so we tried to be funny, and as you can see in some of our main slides. So we're going to talk about energy usage really quick, and I know we are very short on time, so I'm going to go quick. Hopefully you all can understand me still if I talk fast. But really quick, energy usage. So we do look at the energy usage of the building. So now this is the quantitative part, right? And we look at how our buildings performed and also the user comfort survey side by side. So there are some projects that we do prediction energy modeling. So that's called the predicted. So Central Texas and the CHIPS Middle School did have predicted modeling done on them. But then we also, because of this POEs, we are able to show how our buildings are performing after occupancy. And we really have some that are pretty high performing buildings. The Energy Star building we did not model it, but it was designed to get as many Energy Star rating. And that's why we use the CBEX 2003 data. Now, for those of you familiar with AIA 2030 commitment, it uses CBEX 2003 data, which is 75 kBTU per square foot per year for a standard building. And if we do not predict it, that's what we compare it against. So Energy Star was 22.7 kBTU. Our CHIPS was 33.1 kBTU per square foot per year. The reason the Houston Middle School was so high was because we were asked to reuse existing chillers by the district. And we also have some HVAC cost data right there. And really, if we could tell that data to the district as to how much they're going to spend on the operations of the building, they did not seem to have saved a lot of money during construction, during the HVAC costs. So some of the, again, this is all on this slide, but Energy Star Middle School that performed really well did have geothermal for most of its HVAC, lots of LED lighting. So that definitely helped with its energy usage. And because we do POEs, we keep a track of all of our buildings. And you can see these are, we have some net zero energy schools, some net zero ready energy schools. And that is how we keep a track of how they are performing after occupancy. And again, when we predict the performance and it could be way off of prediction, then we can go back to our schools and say, there could be something wrong in the way it's operating or in testing and balancing. And let's go back and look at the systems again. And because we've done this POEs, and again, let's talk about POEs, not just quantitative. That is, well building standards is definitely telling us that we cannot ignore what users want. And Center for the Built Environment came up with this award called the Livable Buildings Award, which puts those two things together. It says for the building that gets the highest user satisfaction and the lowest energy usage is awarded that award. And this Energy Star Middle School in Central Texas won that award among 40 projects worldwide that were surveyed under the CBE survey in that year. And we all as designers thrive on our awards that we get for designs, but having our users give this award is a really big deal. So we are constantly, learning from the buildings that are high performing, not just with energy, but also with high performance when it comes to user satisfaction. And how can we make all our buildings perform well? And again, not all categories are great in one school, right? This is a school where thermal comfort is low. So we've been going back and trying to understand how we can get all categories to perform better. And then finally, I won't read through this, but we always say, why not? Why do we not want to do post-occupancy evaluations? It's something that, like I said, product manufacturers do it, and we build a building for 1,500 kids or 3,000 kids when it comes to a high school for years to come. Shouldn't we be learning what's working and what's not working? So I'm just going to leave it at that. And we'll open it up for questions.
Thank you so much, Shivani. I'm pretty excited to hear. Let's see if we have any questions coming in. If we don't, we do have a few moments for one or two questions. And I guess I'll go ahead and ask one since no one's popped up. One of on the survey, it talked about mechanical noise. And I thought that was really interesting to kind of dive into that, especially when you are connecting that with energy efficiency. So what can you do to really address mechanical noise?
Great question. So we have been talking about that quite a bit. And I think Christy mentioned a little bit in her slides as well, that definitely make sure that we are not reducing the space for mechanical ductwork as much as we sometimes like to, because we want to keep our occupiable spaces as open as possible. So don't make your chasers too small. Don't make your plenum spaces too small, because that would mean that the ducts will get shallower and that velocity will get more, and that velocity will cause noise issues. We have also, by the way, LEED for schools. It does require acoustics as a prerequisite. And we all have to make sure that we meet, if you have a unit on the outside of the building, you have to have insulation. You have to make sure that sound doesn't come in. So it's not just the mechanical noises inside the building, but also mechanical noises from outside the building has to be considered. So insulation on the exterior units, making sure the ductwork velocity is not too high, and doing modeling. Really, we have got acousticians on the project to really look at all of that to ensure we are, not causing issues later on.
I think, Shivani, I really enjoyed you and Christy's presentation, and I learned a lot. Also, just kind of seeing the user perspective, especially when you start thinking about energy code, because having that kind of output and understanding is wonderful. Well, I thank you all for attending our presentation. Since we haven't gotten any questions coming in, we'll go ahead and end. As a reminder, I'll be following up with an email with the resources, with the presentation and a survey. And I hope that you learned something today, because I know I did. And thanks for joining us. See you next time.
Thank you. Thanks, Sean.